Hello students, I extend a warm welcome to all my students. Today we will study the reactions at the electrodes during electrolysis. We have studied in previous lessons about basics of electrochemistry. That is, what are conductors and insulators? What are electrolytes? We are also familiar with how to check if a substance conducts electricity. We have also learned about the principles of electrolysis. Links of lesson 1 and lesson 2 is given below the video. You can go there for better understanding of the concept. Before we move on to the next topic, let's review the homework from our last lecture. I had given you this homework. Let's talk about it. Question 1 is, which type of compounds can be electrolyzed, why, and what form must they be in? Which type of compounds can be electrolyzed and why? Answer is ionic compounds can be electrolyzed because they contain ions and have charge. To be electrolyzed, the compound should be in ionic form, right? Ionic compound is the compound that is formed by the transfer of electrons between metal and non-metal, metal and non-metal. One more thing, these compounds should be in molten or aqueous form. Okay. It is asked in the next question, what form must they be in? It should be in molten or aqueous form because the ions in solutions are free to move. Because it is easy in molten or aqueous form for the ions to move. Ions are easily moved in molten or aqueous form. Next question is, these questions are given from complete chemistry book, and next question is, what does electrolysis of these molten compounds give? First is sodium chloride. Sodium chloride gives, answer is here, sodium metal at cathode, right? Cathode is negative electrode, negatively charged electrode, right? And chlorine gas at anode. Anode is positively charged electrode. Okay. See, sodium chloride contains sodium ion, sodium cation, and chloride ion. It is an chloride ion means it is an anion. Negative charge is anion. So cation will move towards the cathode and anion will move towards the anode. Next is calcium fluoride. Calcium fluoride. Molten calcium fluoride. In molten calcium fluoride, calcium will move towards at cathode. Calcium will move towards, calcium fluoride is CaF2, right? Because the valency of calcium is CaF2. Valency of calcium is 2 and fluorine's valency is 1. So formula would be CaF. Calcium at cathode, right? Calcium has 2 plus charge and fluorine has 1 charge, minus 1 charge. So fluorine will move towards anode and calcium becomes calcium metal and fluorine becomes fluorine gas. Always remember how to write it. Ca2 plus cation will become calcium metal and fluoride ion will becomes fluorine gas. So it would be diatomic at anode. It would be diatomic at anode. Next is molten lead sulfide. Next is molten lead sulfide. molten lead sulfide, it will give lead at cathode. Lead sulfide is something PbS. Formula of lead sulfide is PbS, right? Because the valency of lead is 2 and valency of sulfur is 2. So the formula would be PbS. And here lead being a cation move towards cathode. Okay. And sulfur being an ion move towards anode. Right. Okay. Let's do the second part, that is aluminium oxide, molten aluminium oxide. See, aluminium is obtained by the electrolysis of its oxide, that is alumina. Alumina is the ore of aluminium, and we can get aluminium from the ore of aluminium, that is alumina. It is alumina, right? Overall reaction will be, it is written here, Al2 O3. Okay, it gives 2 moles of aluminium ion, right? The charge is 3 positive, 3 cation, right? 3. Charge is 3 because the valency of aluminium is 3. Atomic number of aluminium is 13. So it would be 2, 8, 3. So aluminium needs to give 3 electron. And after giving 3 electron, aluminium becomes aluminium cation, right? Plus, so alumina will give aluminium ion plus oxide ion. 3 moles of oxide ion. 3 moles, right? Why do we need to write 2 and 3 here? To make it balance. Because here we can see the 2 aluminium metals are here and 3 oxygen atoms are here. I would like to repeat it. 2 aluminium atom here, 2 and 3 oxygen atom are here. So 3 moles of oxygen here and 2 moles of aluminium would be here. Right? See the reaction at cathode. Reaction at cathode. Look here. We need to correct it. It is 2Al, 2Al, 3 plus. It would be on the upper side, right? Plus 6 electron. It means we need to add 6 electron to get aluminium metal because it has aluminium. See, aluminium cation means it has already given 3 electrons. That's why it is a cation. Okay. Now we need to get back. Now we need to get its original aluminium metal state again, right? To get aluminium again, we needs to give 6 electron to this cation. Now we can get 2 moles of aluminium metal, right? Why 6 electrons are here? Because we have 2 atoms of aluminium here. I hope you are getting what I am explaining, because we have 2 atoms of aluminium here, and each aluminium atom has, each aluminium cation has 3 charge, right? It has given 3 electrons. So for 2 aluminium, to get 2 moles of aluminium atom, we need to give 6 electron, and then we can get 2 moles of aluminium metal, right? I hope it is clear. I would like to say these 6 electrons are because we need to give 6 electron to get 2 moles of aluminium metal. I hope it is clear to you. Next is reaction at anode, right? See, oxygen, it would be O2 minus, right? Because oxygen is negatively charged. So it is an oxide, right? O2 minus. It has negative 2 charge, right? 2 minus charge. It is an oxide, right? Okay. But we have 3 atoms of oxygen here, right? 3 atoms of oxygen here. So it should be 3 here. 3 moles of oxygen would be here. Okay. Now we need to lose 6 electrons because we need oxygen gas here, oxygen molecule. So it means we need to lose 6 electrons here, right? Because for one oxygen, to get one oxygen atom, we need to lose 2 electrons. For it means 3 atom of oxygen will lose 6 electron, and then we can get 3 atom of oxygen, right? And when 3 different oxygen of atom combined with each other, right, they will give oxygen molecule, right? See, I hope it is clear to you. 3 oxide, 3 mole of oxide. It is an ion. Always remember, it is an ion, it is an atom, and it is a molecule. Okay. From your level, students are usually do such type of mistakes in exams and they lose their marks. So oxide, after losing 6 electron, become 3 mole of oxygen atom. Right. We did till here. Now the next question is, name the products at each electrode when these aqueous solutions are electrolyzed using inert electrode. This one. Now we have to do this one. Name the products each electrode. See, first is concentrated solution of magnesium chloride. Concentrated solution of, always remember, okay, just focus on this, whether it is concentrated, whether it is dilute, right? It makes a difference, right? Concentrated solution of magnesium chloride first. Let's see the ions present in concentrated magnesium chloride. The ions present in solution Mg 2 plus, okay, chloride ion, okay, because water is here. Water is also here because it is a solution. Although it is a concentrated solution, but there must be some few hydrogen ions and hydroxide ions, H plus hydrogen ion and hydroxide ion, right? So we can say there would be competition between magnesium. It should be like this, Mg2 plus and H plus. Competition between Mg2 plus and hydrogen ion. So this competition would be towards cathode, because these are cations, so they must be interested in moving towards cathode. Okay. And the competition would be between chloride ion and hydroxide ion, because these two, chloride ion and hydroxide ion, would be interested in moving towards anode. Right. Let's see the reactivity series for magnesium and hydrogen. Right. Because which one is going to discharge towards cathode? See, this is the order of reactivity, right? And we can see hydrogen is less reactive than magnesium. Hydrogen is less reactive than magnesium. And always remember, the less reactive element is going to discharge first. What I'm saying, less reactive is going to discharge first, because the one that is more reactive is capable of maintaining its ionic state. So here hydrogen is going to lose its ionic state and hydrogen is going to convert it into hydrogen gas. Right? So far, it means formation of hydrogen gas towards the cathode. Right? When we compare from magnesium and hydrogen, hydrogen being less reactive is moving towards the cathode and losing its ionic form. Now it becomes hydrogen gas from H plus to H2, right? So it is written here, formation of hydrogen gas towards cathode, because hydrogen is less reactive than magnesium. Always remember, more reactive element is not going to lose its ion. So hydrogen lose its ion to become hydrogen gas. I hope it is clear to you. Which one is losing its ionic state? Less reactive element is going to lose its ionic state. Always remember. Okay. let's see what happens at anode, right? It is for, see, it is for cathode, right? It is for cathode. Okay. What happens at anode? Now here the competition between chloride and hydroxide towards anode, right? Let's see which one is going to win. Right? Which one is? Let's see which one wins the race towards anode. Let's see the series for anions. Series for anions, it would be SO4, 2 minus, sulfate, nitrate, chloride, bromide, iodide, hydroxide, right? So same concept is here. Reactivity decreases from top to bottom. Reactivity decreases from top to bottom, right? So the ions, those are present at the bottom, discharged easily, easier to discharge. See, let's see. See, one important thing is here, as it is a concentrated solution, right, students? It is a concentrated solution, right? It means it has less number of hydroxide ion, right? Okay. It has less number of hydroxide ions. It means here hydroxide ion is not going to discharge. Okay, although the concept is saying, because as I told you, less reactive anion will discharge first. Less reactive anion or cation will discharge first. But here, as the number of hydroxide ion is less because the solution is concentrated. So instead of hydroxide ion, chlorine will discharge. Chloride after discharging, chloride after losing its anion will become chlorine gas, right? So who is going to discharge at anode? From in between chloride and hydroxide, chlorine will discharge to become chlorine gas. Always remember, if a concentrated solution of halide means a compound containing chloride, bromide, or iodide ions from 7th group, then chlorine, bromine, or iodine form. Right? So then chlorine, bromine, and iodine form. Next is a dilute solution of copper to sulfate. See, in dilute solution of copper to sulfate, copper will, look here, copper sulfate, it will give Cu2 plus ion and SO4 2 minus ion, right? Okay, let's see the ions present at cathode. So at cathode, there may be, at cathode, there should be, there may be the competition between copper and hydrogen, right? Okay. Let's see the ionic equation at cathodes. Cu2 plus, it means it should lose, I would like to repeat it. It is Cu2 plus, right? Copper cation. It means it needs to gain two electrons to become copper metal, right? It is an ion, it is an metal. Always remember, right? It needs to take back again. It's the two electrons that it has already given when it formed, when it was an ion, when it formed its ionic state, right? Now it becomes copper, right? And there may be the possibility of hydrogen ion, because hydrogen is also hydrogen is an cation, right? So it can take 2 electrons to become hydrogen gas. There are two possibilities, right? So what happens here at cathode? At cathode, I would like to write it again. Cu 2 plus, after gaining 2 electron, becomes copper metal, right? Copper metal. Or there is a possibility that hydrogen ion, after gaining 2 electron, become hydrogen gas, but copper wins the race. Here, copper wins, right? Let's see the reactivity series. What happens? Let's see the reactivity series. Series of cations. When we see the series of cations, it would be like potassium, sodium, calcium, magnesium, zinc, iron, lead, hydrogen, copper, silver. Okay. So as we know very well, reactivity decreases from top to bottom. From top to bottom, reactivity decreases. Okay. And the less reactive cation will lose its ion first. Right. What happens here? See, copper is less reactive than hydrogen. Look here. Copper is less reactive. Then hydrogen, right? So copper is going to lose its ionic state and it becomes copper metal. At which electrode? Obviously, as it is a cation, so it's going to lose its ion at towards cathode. Hope it is clear to you, right? One more thing, there is an important note. Always remember that anions, always remember anions like sulfate, okay, and nitrate will never be discharged in electrolysis. Remember, okay? Always remember this concept. What I said? Anions like sulfate and nitrate will never be discharged in electrolysis. Okay? Okay. If you want to learn it as a note, always remember at the anode, hydroxide ions are usually discharged to form oxygen gas, right? I would like to repeat it again. At the anode, hydroxide ions are usually discharged to form oxygen gas, unless the electrolyte has a high concentration of halide ions, like chloride, bromide, or iodide. And at the cathode, hydrogen ions are usually discharged to form hydrogen gas, unless copper 2 ions or silver ions are present. Always remember this point. Okay. So here, let's see what happens at anode. What happens at anode? At anode, see, at anode, I'm going to write, see, I've already written it here. This is the series for anions, sulfate, nitrate, chloride, bromide, iodide, hydroxide, right? As I told you, less reactive is going to lose its ionic form first. But always remember, it is a note that it is a dilute solution of copper to sulfate, right? Here in this case, as it is a dilute solution of copper to sulfate, it means it has more number of hydroxide ion, right? I'm writing it again here. See, just a minute. Sulfate, nitrate, chloride, bromide, iodide, and OH minus, right? Hydroxide, right? Hydroxide, because reactivity decreases from top to bottom. So the rule is saying that hydroxide should, OH minus should lose its ionic form, but it is a dilute solution, right? It means we have more number of hydroxide ion here in the solution. So instead of sulfate, hydroxide is going to lose its ionic form. It discharged and it gives oxygen at NO, right? It discharges and gives oxygen at NO. It is 2H2O, right? It should be like this, 2H2O. It gives oxygen plus 4 hydrogen plus 4 electrons. So it means in the electrolysis of copper sulfate solution, copper metal produced at cathode and oxygen gas at the anode with H2SO4 as a byproduct. Right? It was the homework. Let's move towards the next topic, that is the reactions at the electrode. Let's start with what happens to the ions in the molten lead bromide, right? Reactions at the electrode means here we will talk about which ion is going to move towards cathode or anode, right? So we are going to talk about the reactions occurring towards cathode or anode electrodes. Cathode and anode. Okay. What happens to ions in the molten lead bromide? In molten lead bromide, the ions are free to move. Right? Ions are lead bromide. Ions are free to move. This shows what happens to them when the switch in the circuit is closed. See, this is the molten lead bromide. Lead bromide. Ion would be Pb2 plus and Br minus. The formula is Pb Br2. Right? See, so we can see the bromide ion here in the solution and lead ions are also here. So first ions will move, opposite charges attract. So the positive lead ions move to the cathode. It is cathode, it is anode. Positive lead ion move towards the cathode and negative bromide ions move towards the anode. Moving ions carry the current. Always remember, moving ions carry the current. Okay. At the cathode, lead ions each receive 2 electrons and become lead atoms. Lead ions, see, it is lead ion 2 plus. It is Pb2 plus after receiving electrons, right? It has taken electron from the negative electrode, that is cathode. Okay. After receiving electron, it becomes lead atom, right? Lead ion, right? Lead ion. Just a minute. Lead ion, after taking 2 electrons, becomes lead atom, right? Okay. At cathode. Students, please excuse me for my poor handwriting. Just a minute. Okay. And here we can say this is bromide ion at anode. The bromide ions each give up an electron after giving electron towards the anode, right? It becomes bromine gas, right? Equation would be 2Br. We need 2 bromine atom to make bromine gas because bromine is diatomic. So it becomes bromine gas after losing 2 electron. We can minus 2 electron on the left hand side, or we can release 2 electron from here. I hope you know the difference between. See here, suppose we have to add the electrons. It means we have to add 2 electrons on the left side, right? If we want to lose 2 electrons, it means we need to write 2 electrons on the right side, right? Right side means loss of electron, right? And here it is gain of electron. Okay. Gain of electron is reduction, right? And loss of electron is oxidation. It is the reduction and it is oxidation, right? So it is reduction. It is reduction because it is loss of electron, and here it is oxidation because ions lose electron. So it is oxidation. Okay. Always remember, oil rig, oxidation is loss of electron. Oxidation is loss of electron. This is the mnemonic. Reduction is gain of electrons. Overall, electrolysis is a redox reaction because oxidation and reduction occur together. Reduction takes place at the cathode and oxidation at the anode. The reactions for other molten compounds follow the same pattern. For a concentrated solution of sodium chloride, concentrated means we have hydrogen ion and hydroxide ion, but in few number, right? We have a less number of hydrogen and hydroxide ion. This time ions from water are also present, but the number of hydrogen and hydroxide ion is less than the ions of sodium and chloride. Look here at anode. Anode here, the same concept is here. This solution contains sodium ions and chloride ions, right? From the salts NaCl, and hydrogen ion and hydroxide ions from water, right? Positive ions go to the cathode and the negative ions to the anode. At the cathode, hydrogen ions accept electrons. Since hydrogen is less reactive than sodium, right? So it would be hydrogen ion after accepting electron becomes hydrogen because it is a diatomic gas. So there should be 2 hydrogen cation and there should be 2 electron. So hydrogen cation after gaining 2 electron become hydrogen gas, right? So here it is reduction at cathode. Reduction at cathode, right? Always remember reduction at cathode, RAC. Always remember RAC. Reduction at cathode. Reduction at cathode. Okay. What happens at anode? The chloride ions give up electrons more readily than the hydroxide ions. Okay. And chlorine gas bubbles off. What happens here? Chloride ion, it should be 2 ions, 2 chloride ions, right? It becomes chlorine gas after losing 2 electrons, right? So here it is oxidation. Oxidation is the loss of electron. Because here it is loss. It is the loss of electron. And here it is gain of electron. Correct? Let's move further. Right. When the hydrogen and chlorine bubble off, sodium and hydroxide ions are left behind. So a solution of sodium hydroxide is formed. Right. Next is for a dilute solution of sodium chloride. What happens when we take dilute solution of sodium chloride? Here we can see there will be more number of H plus and OH minus ion, right? As well as we have sodium ion and chloride ion also. The same ions are present as before, but now the proportion of sodium ion and chloride ion is lower. Since this is a dilute solution, right? So the result will be different. At the cathode, hydrogen wins as before because it is a dilute solution, right? And hydrogen is less reactive than. There's a competition between sodium and hydrogen being less reactive than sodium. So it wins the race and it loses its ionic form and it becomes hydrogen gas, right? The equation would be at cathode, the reaction will be 4H plus 4 electron. After gaining 4 electron, here it means it gains electron. It becomes 2 hydrogen molecule, right? At the anode, hydroxide ions give up electron because we have, as the solution is dilute, and we have more number of OH, more number of hydroxide ion, right? So hydroxide ions give up electron. Hydroxide ions give up electrons because the number of hydroxide ion is more than the chloride ion as it is a dilute solution. Because it is a dilute solution, right? So as hydroxide ion discharged here at anode, as a result, oxygen gas released. Release of oxygen gas, right? The equation would be hydroxide ion. It is an aqueous form. It gives oxygen gas plus water plus 4 electron at anode. Look here. At the anode, hydroxide ions give up electrons. Since not many chloride ions are present, oxygen bubbles off. Hydroxide ions, oxygen gas, water, and 4 electrons. Oxygen gas is released. When the hydrogen and oxygen bubble off, the sodium and chloride ions are left behind. So we still have a solution of sodium chloride. The overall result is that water has been decomposed. Okay. Now, how to write the half equations for the electrode? Right. How to write the half equations? How to write the half equations for electrode reactions? Okay. Students, you may be asked to write half equations for the reactions at electrodes. So there are few steps to write the half equations. Steps to write the half equation. For that, first name the ions present and the products. What we have to do? First, we have to name the ion, write the ions. First, we have to write the ions present and the products also. And the products. Okay. Second, write each half equation correctly. Write each half equation correctly. How to write a half equation? First, give the ions its correct charge. Okay. Always remember the valency of the element, correct charge. Second, remember positive ions go to the cathode and negative ions to the anode. Right? Next point is write the correct symbol for the element that forms. For example, Cl2 for chlorine, right? It should be Cl2, right? Its molecular form. Cl2 for chlorine, not Cl. Remember, should not Cl. Don't write it, right? Not Cl. It should be Cl2. Next is the number of electrons in the equation should be the same as the total charge on the ion, right? Total charge on the ion. In it. Right. Let's take the example for this. Let's see the example. Suppose, example, electrolysis of molten magnesium chloride. Electrolysis of molten magnesium chloride. Okay. Magnesium ions and chloride ions are present for that, right? Magnesium ions and chloride ions are present. Are present. Okay. Then the formation would be magnesium and chlorine. Magnesium and chlorine form. Ions Mg 2 plus and chloride ion. At the cathode, Mg 2 plus after gaining 2 electron. Magnesium cation after gaining 2 electron becomes magnesium metal. At the anode, chloride ion after losing 2 electron becomes chlorine gas. Always remember, when we need to lose electron, we need then, if we want to show that electron is losing, then we write electrons, then we write electrons or add electrons at right hand side. Okay. When we need to add electron, then we write electron at left hand side, right? Here we are adding electron, and here loss of electron, right? Here we are losing electron, loss of electron. Right? Okay. Let's balance it. 2 chloride ion becomes Cl2 and 2 electrons. Because it is 2 chloride ions, so total charge of 2 minus, right? Always note that it is also correct to write the anode reaction. We can also write the anode reaction like, okay, don't get confused. 2 chloride ion minus 2 electron, it is also correct, right? It gives chlorine gas. Right. So overall reaction would be magnesium 2 plus, it was in liquid state, plus 2 electron after gaining 2 electron becomes magnesium metal, right? It would also be in liquid state, right? And chloride ion in liquid state becomes chlorine gas after losing electron, right? I hope it is clear to you. I hope the concept of the reactions at the electrodes, now we are familiar with the reactions at the electrodes, okay? And we have got what is the way of, what is the behavior of cations and anions towards anodes and cathode, right? So Here's the homework. Try to do this. Try to do it yourself. We will discuss this in next session. Hope you have enjoyed the session, right? You have got your all doubts cleared in this session. Bye-bye.